So we'll be looking today at abstraction. And sort of in exploring this, I first want to go sort of why we use abstraction. What's the motivation for abstraction? And so, real world or imagined objects can be very complex and have lots of little details. So for example, this is a diagram of like a real robot leg from a robot from a company called Boston Dynamics. And you can see there's lots of like little intricacies about the structure of the inside of the material. It has lots of little like joints and hydraulic tubes. Well, I think they're hydraulic, but sort of tubes, actuators, and it'll have lots of like circuitry going on. And this is all very complex and can be like it's a lot basically. Like to fully describe like a robot would in real life, it'd be very complex. Like imagine having to describe like all the different positions of all like the different circuitry fully and describing like all the different components inside it. And for many like uses, we don't need all that detail. For example, if you're trying to represent a robot on TV, you won't really want to know or need to know like all the details of how that imagined robot might work inside. You don't need to like create a full robot to do that, or like have plans for like the inside of what that robot would do exactly. Or if you do, they could be like very broad and not like exact details. Like you wouldn't need to know like what little wires are going on in there and that. So because in TV, like obviously it's recorded and it's not real, so you can like simply have like the outside of a suit made and puts a person in there to like play the robot, and in that way like you don't have to deal with that detail. And so abstraction, what is it? So abstraction is the removing or hiding of unnecessary details from a problem so that the important details can be focused on or more easily understood. And so with that example with the TV robot earlier, we sort of hide or remove the details of like how a robot would work inside to be able to focus on sort of playing on TV. And for a different sort of example, imagine like you've seen someone pose somewhere and you want to like describe it to a friend over the internet. And so like a person like describing a whole person posing like in full detail could be a lot, because like you'd have to provide like a physical description of what a person is like and sort of like the details of like they have a skeleton, they have muscles, these muscles were like activated in this way, this like man like had these physical dimensions, his hair was like this. And that's not really what you care about in like describing the pose. Like that's that's sort of not very relevant to you. So what you could do instead is like draw a little stick figure like here, and that sort of like throws away a lot of detail you don't care about, like the person's clothes, like their dimensions, like things like that. Like it's a lot of details, like I don't know how their heart was beating or like things like that. So it like throws away a lot of like details that exist in real life that you don't care about, and it just gives you like how their arms were moved and that. And sort of more generally, like a stick figure is like an abstraction of like human anatomy, where like humans anatomy is quite complex, but if you like want to focus on certain details, like we have two arms, we have two legs, we have a head, a stick figure is a good abstraction of that. And so I'll move on to sort of more computing like example of this. So imagine you have like a computer system in a mechanic shop, and now like in mechanic shop you have to like keep people's cars for certain periods whilst you're fixing them. So you'll need to like store what cars are being like fixed at the moment, so you know what's going on with that. And you might want to do this like in a database. But cars are very complex objects. They have like tons of systems, like tons of like wires, pipes, metal structures, springs, dampers, like seats, fabric, etc. And to fully describe one, like, you'd have to do a lot. Like, you'd have to describe, like, the exact patterns of rust on, like, the bottom of your car, where some dirt is, like, where this little, like, wire goes exactly, what the weave of the fabric is, or, like, what material fabric is being used in particular places. And that's, like, a lot, to fully describe a car, like, it'd take a lot of data, about the car, especially, like, if you're not just producing one, if you, like, have to take into account the specifics of, like, an actual real car in front of you that might have, like, particular wear or dirt. And that's a lot. And so what do we do? Well, you might have a bit of an intuition for this, because obviously, like, when you might be describing a car to someone, or you want to, like, point out a certain car to someone, you're probably just going, like, oh, it was, like, it was a blue, like, I don't know, like a blue hatchback or something, or, like, a blue truck or something. And so, because those are, like, the most apparent details, and you can sort of work with those, you don't need all the small details. And it's a similar approach here, essentially. You might, like, store the car's number plate, make, model, and color. And that will be, like, enough for you to work on it on the, in your mechanic shop. And obviously, like, number plates should be unique, so that's enough to, like, uniquely identify it as well. And through that kind of system, we can, like, sort of easily store, what, like, cars are in our garage, using, like, quite a small amount of information. So yeah, that was a bit about abstraction and a few examples that I hope make it clear. Thank you.